We got a hollow tube. On one end, it's open. On the other end, it's closed. By the way, if you're a musician, you do like wind instruments, let me know if you notice this. But there are certain frequencies that can be played and then some that can't be played. This is the formula, so it's going to be wavelength is equal to 4L. That's the length of the tube. And then N. Obviously, as N gets bigger, the wavelength itself gets smaller. So if we want to find the lowest, we start off with N as 1. So the longest wavelength possible is 1.8 meters. How is it possible though, right? Because the tube itself is only 45 centimeters. This is my tube, right? Now, there are only two constraints when it comes to wavelengths here. When the wavelength exits on the open end, it has to exit on an end. So it has to exit either here or here. It's an antinode, the highest peak of the sine wave. Now, when it hits here at the closed end, it has to hit at a node, at the zero, at the very center. So with those constraints, the longest wave possible is going to be 1/4 of a sine wave, which just pretty much goes like this.